Alrighty, section 3.2, slope of a line. Slope of a line. Very important. Remember, my notes are just a little bit different than yours, only in the sense that they're spaced out differently. All of the same stuff should be there. Alrighty, objective number 1. Using rise over run to find slope. So let's define slope, that word, first off. What does that mean? What does slope mean? What is a slope? You guys talk about it for a sec. Alrighty, I hope somebody said the slope, the steepness of a line. Now, in our case today, we'll be talking specifically about linear lines, but slope can be found in a lot of lines. It's just the steepness. How fast are you rising and running? Like how fast do you go up and down? You can have positive slopes. Positive slopes go this way, right, going up. You can have negative slopes. You could have, we'll talk about zero slopes, and we'll talk about undefined slopes in just a sec. But you can have a lot of different kinds of slopes. So the positive ones go up, the negative ones go down. To find them, you use something called rise over run, right? So how far did you rise, how far did you run? And we've actually kind of seen this concept a little bit in the last section when we were working with distance. If you recall, we had 2 points, right? Look something like this. And we wanted to find the distance in between them. We would say, okay, to do that, I can look at how far down or how far up and down it went, and I can look at how far over it went, and I can use the Pythagorean theorem to find out how far that distance is. Luckily, we can use those same two numbers to find the steepness. So the distance and the steepness are very, very, very closely related. Instead of calling it d, we're going to call it m, right? Because it's not the distance. We're not finding the distance. We're finding how steep it is. We're going to call this slope the m every single time. But we're going to use that same up and down, that rise, and that same run, that horizontal length. So, and we'll put them over each other, rise over run. So in other words, rise over run is the changes in the y's over the changes in the x's, or y2 minus y1 over x2 minus x1. Now remember here that the y2 and the y1, so y2, it's not something super fancy, it just means the second y, right? So if you have y1, that's the first y. If you have x2, that's the second x, and x1, that's the first x. And that's just the formula to plug into. Same defined as last time with the points and the distance and the points for the midpoint formula. So hopefully you've seen these ones before. I know if you took my class a few years ago, you definitely have seen these before. But we're going to use these to find the slope of this line down here. So let's take a look at this line here. Alrighty. So over here, we can see they've picked out 2 points for us. Let's just use those so we can stay on the same page. 1, 5 and 2, 8. Let's go find those here. So 1, 5, remember that's x, y. So you want to make sure you go out 1 and up 5. Let's see, that's right about here. So that's going to be our 1, 5. And then our other one, 2, 8. So we're looking at this point and this point, 2, 8. So out 2 and up to 8 would be right about there. Alright, so we got these 2 points. You can use any 2 points, though the steepness of the line for a linear line will be constant no matter where you are on the line. So you can use any 2 points you want when finding linears. That changes a little while down the road, but right now you can use any 2 points you want. Alrighty, so let's do the same thing we did for distance, right? Let's look at that rise and that run. Let's see, how far did this one go up? Let's see, from 5 to 8, that's 3 units. So it went 3 units up, right? And then how far did it go out? It went out from 1 to 2, that's 1 unit. So our slope would be rise of 3 over run of 1, or a slope of 3. It's a slope of 3. Fabulous. That's what that way we call geometrically, right? On the graph, geometric. So if we can do it geometrically, definitely always plot 2 points and count. Little harder if you've got fractions and decimals and stuff, but luckily there's also another way we can do this, an algebraic version. The algebraic is using the formula, right? So if we look over here, they've actually done it for us. That formula, remember the second the second y minus the first y. Well, we already talked about that, the changes in the y's, right? From the 8 to the 5. Or 8 minus 5, that was 3, right? So same concept, just doing it in a, a fraction or a formula instead of on the graph. 8 minus 5 is 3. Same thing with the x's, right? We saw that the x's move over 1 from 1 to 2, or 2 minus 1 equals 1. We end up getting the same slope of 3. So if you want to do it geometrically, that's totally fine. If you're a visual person, kind of like myself, you need to see stuff on a page, then definitely, do a graph every single time, but it will be much easier if you can just do it algebraically and you can remember that formula, the changes in the y's over the changes in the x's. All right, let's do it again with this example down here. So we're going to scroll down just a little bit. So finding the slope of the line given these 2 points. We're first going to start it geometrically, then we'll do it algebraically. So geometrically, we've got 2, -1. Let's go plot that on the graph. Out 2 and down 1 would be over here, right? So that's our first point. That was this point here. And then I'll use a different color for my other point. We'll use blue. Of -5, 3. Now remember, that doesn't mean down 5, out 3, right? We do the x first. So that means back 5 and up 3. Back 1, 2, 3, 4. Oopsie, that was not enough. So back 1, 2, 3, 4, 5, up 1, 2, 3. Right there. Okay, good. All right, so now we've got these 2 points. Let's figure out what the steepness between them is. So let's draw a line in between them. At least a decent line, right? And then we'll count how far up they went and how far over they went. So how far up would be our rise. All right, it's looking like, let's see, I went 3, 4, right? Now remember, I'm measuring how far up between the 2 points. I'm not measuring from the axis. That's something we see a lot. Don't measure from the axis, measure from the points, like how far the points are apart. And that looks like 4. And now let's measure how far across. So it looks like across, use orange. Across would be, let's see, 1, 2, 3, 4, 5, 6, 7. 7 across. Cool. Did I plot that right? Nope, yep, I plotted that right. So 4 and 7, fabulous. Questions so far? Awesome. All right, so then we do the rise over the run, right? So 4 over 7. Tiny thing though. Remember, up here, we went out 1 and up 3, right? A nice positive slope. Here we did not go up 4. We went from here down 4. So this is actually going to be a -4. A -4, down 4. And now, so this would be a -4 over a run of 7, or a slope of -4/7, right? It doesn't really reduce, so that would be our fraction. Alrighty, let's see if we get the same thing algebraically. So here we've got our 2 points, right? I'll try to stick to colors. Our slope formula, if we recall from up here, is the changes in y's, y2 minus y1 over x2 minus x1. And so what would be our y2? Well, that means our second y, right? Our second y. So that would be 3 minus, what's our first y? -1 over our first x, or I'm sorry, our second x, -5, minus our first x, which is 2. Alrighty, so I just plugged it in as I saw. This blue one right here was that 3 there, right? And then this -5 was on the bottom. It's the blues minus the purples. Okay, now we'll simplify a little bit. 3 minus a -1. Remember, minus a negative makes it a positive. So we've got 4 over -5, take away 2 more, -7. And since it's a fraction, the negative can go on either the bottom or the top. -4/7 is our slope. And that's exactly what we got when we did it geometrically. So either way, we got -4/7 as the slope. Awesome. Alrighty, let's take a look at this finding the slope again, right? We'll find the slope, but this time we're going to do it from an equation. So we've got this equation here, 4x minus y equals -8. Recall, this is what it looks like in standard form, the standard form of an equation. where you've got a number times x minus another number times y equals a constant. So ax plus by equals c. Now, we still need to find the slope, we still need 2 points. What can we use as those 2 points? Well, we could plug in any 2 points we wanted and find the slope. That's absolutely true. But instead of doing that, because you never know, you're going to end up with fractions, and then you have fractions and fractions, it'll be horrible, we should look at 2 very specific points, ones we already know how to find. Anyone know which ones I could think of? Hint, hint, they're in my little box. That's right, the x and y intercepts. Let's find those. We'll use the x and y intercepts as our 2 points. We already know how to find those from the last section. It'll be very easy to just repeat the process here. So let's recall my x-intercept. Well, that's where I cross the x-axis, right? And since I'm at the x-axis, I've gone up and down nothing, right? So that is where my y equals 0, right? I've gone up and down nothing. So that's where my x-axis would be. That's my x-intercept. So in order to find my x-intercept, I plug in y equals 0. Well, here's my equation. 4x minus y equals negative 8. And I know y equals 0, so I'll plug it in for y. So 4x minus 0 now equals negative 8. Well, anything minus 0 is not going to change anything, so that kind of just goes away. I get 4x is equal to negative 8. Notice using the 0 is very, very simple, right? So that's why we want to use our x and y intercepts. Then divide by 4, you get x equals negative 2. And so our x-intercept would be negative 2, comma 0. Now, this last part here, if solving for a single variable is difficult for you and you're not quite as fast, then you definitely need to practice, okay? So use some problems from the book, or come see anybody after school, or email me, that's fine too. But this should be fluent by now, being able to plug in a number and then solve for the other one. If that's still sort of a weak area for you, that's okay, right? That's okay, but you do need to practice, okay? Because it's only going to get more complicated from here, and if that's still an issue with you, you need to fix it, okay? Now, I'm not saying you're like behind in the class or anything, don't worry. I'm just letting you know that you need to make sure you get stuff like that. Get your questions answered is what I'm trying to say. Make sure you always get your questions answered. All right, let's do the same process for the y-intercept now. So the y-intercept is the same yet opposite, right? Instead of looking at the x-axis and where it crosses the x-axis, we're going to look at where the line crosses the y-axis. When it crosses the y-axis, we've gone out nothing, right? We've gone over nothing, so our x would be 0. So for x-intercept, the y is 0. For y-intercept, the x is 0. And so we'll plug in x equals 0. So x times 0 minus, I'm sorry, not minus 8, minus y. Oh no, pardon me. Okay, hold on, sorry, technical difficulties. Just erase that and start over. 4 times 0 minus y equals negative 8. Anything times 0 is just going to go away. So it would be 0 minus y, and 0 minus y doesn't change anything. So minus y equals negative 8. And then divide by negative 1, you get y equals 8. So for x is equal to 0, let's do green. Let's do green that's not ugly. Y is 8. 8. Alright, so we have our 2 points, negative 2 comma 0 and 0 comma 8. Now, why were we doing that? Do you remember why we found the x and y intercepts? Because that definitely wasn't in the question. The question is find the slope of the line, right? So if we need the slope of the line, we found the x and y intercepts so that we could use the slope formula. So the last part of this problem is to use the slope formula, y2 minus y1 over x2 minus x1, right? That's what we needed to find. So in order to have an x2, a second y, or a second x, we needed to have 2 points. And that's why we found our x and y intercepts. So let's go use those now. We'll do the x-intercept as our first point, the y-intercept as our second point, though that is entirely up to you. It should work out either way. So our second y would be 8, and our first y would be 0. Also, again, using the 0, right, the y-intercept, and the x-intercept gives us zeros, and that makes our computations pretty straightforward, right? 8 minus 0, that's really nice. Over our x's would be 0, second x is 0, minus our first x of -2. That one I have to be a little more careful about because it's minus a negative, but it's still pretty straightforward. All right, 8 minus 0 over 0 minus -2 reduces down to 8 minus 0 is 8. Let's see, 0 minus -2, what happens there? That's right, we get a positive 2. So our slope, 8 divided by 2, is 4. Alrighty, so 3 parts to this problem. Find the x-intercept, find the y-intercept, find the slope. Pretty straightforward though, right? Pretty straightforward. Using stuff we've done over and over and over again. Or at least we've seen the last section. Alrighty, let's talk about 2 different types of slopes now though. Like I said before, way at the beginning, we have, oops, where my box went, sorry. We have a bunch of different types of slope. We have positive slope, negative slope, and then we have 2 different ones called zero slope and undefined slope. One of which is going to be this equation, one of which is going to be that equation. If you recall from the last section, these are those special types of lines, those horizontal and the vertical. So if you remember, horizontal, side to side, vertical, up and down, right? So horizontal looked like this, and vertical looked like this. Now, which one was which? Which one of these had an equation y equals something, y equals a number, and which one of these had x equal a number? Remember? We'll play a little matching game. That's right, that's right. If you have only y's, right, your up and downs, that means your x's are 0. It doesn't matter what your x's are, so that would be horizontal. So these 2 would be the same. So horizontal is x equals 2, right? And then if you have a vertical line, that's going to be your y's are all equal to 0. It doesn't matter how far up or down you go, right? So you can go up or down as much as you want. That would be your x's. It sounds a little opposite, right? Don't think of your axes when you think of that. Think of the opposite of your axes. Your x is 0 on all of your y-axis, right? So it doesn't matter. Therefore, it's a vertical line, right? So don't think of your axes. That's where people often switch these up. So think of it the other way around. Whatever part you're missing, that's the line you want to draw, if that makes sense. Or you can just memorize it, right? Horizontal y, vertical x. Okay, so then we look at this equation in 2.2a, right? We got 2.2a, y equals 2. What kind of line is that? That would be a horizontal line. Good, horizontal. So now let's think of that slope, right? So we'll think of the slope. We got this horizontal line, and we've got 2 points on there. We can pick any 2 points we want, right? Luckily, it's going to be the same for every single horizontal line, no matter what. But if I've got 2 points on this horizontal line, let's think of that rise over run. It's still a slope, so it's still rise over run. But let's take a look at this. Is there going to be a rise? Is there going to be a rise from on a horizontal line? Are they going to go up and down anything? No, they're not. So the rise is going to be 0, but they are going to run something, right? They're going to run like 2 or 5 or 6 or something like that, right? So it'll be something like 0 over 6, or even better, 0 over some number, no matter what we do. For any horizontal line, that excuse me, that rise is not going to change. That rise is going to be 0. We'll come back to what that means in just a sec, but let's take a look at the other one. Recall that this means, this is the same thing as x equals -1, right? So it's a vertical line. Looks kind of like this, right? And we could pick any 2 points we want on there. Pick any 2 points on the vertical line. Let's again look at rise over run. Is it going to have rise? Is this line right here going to have rise up and down? Definitely, right? It's going to go from -5 to +6 or something like that. So it's definitely going to have some rise, some number. But is it going to run? Is it going to run from side to side? No, it's not, right? Because that x is equal, that y part is not part of the equation. It's not going to run. So it's 0. All right, so this one's always going to be something over 0. Now, which one of these is legal? Which one of these am I allowed to actually compute? If I had 4 over 0 or 0 over 4, which one of these 2 slopes would actually make sense? That's right, the first one, right? You can divide by 0. This one is okay. This one would just give you a slope of 0. anything, 0 divided by anything is okay. However, this one, you can't divide by 0. So this one is what we call undefined. Or you'll see it sometimes in your homework as D and E does not exist. Okay? Now, that doesn't mean you can pick every single slope and call it D and E. It's only the ones for vertical lines, all right? Vertical lines have a do not exist slope. Horizontal lines have a 0 slope. It really depends on whether you're running forever or you're rising forever, right? So if you have a run, you're good. If you have a rise, it's not good. Cool. Hopefully you can catch the difference between those. So over here down at the bottom, you said a horizontal line will have a 0 slope, while a vertical line will have a undefined. I've run out of room. Undefined slope. Undefined slope. So 0 for horizontal, undefined for vertical. But you can write 0 and D and E for does not exist. Alright, cool. Alrighty. If you have any questions about horizontal and vertical, because those can be very confusing, please pause the video now and discuss them. Other than that, we will continue on. Alrighty. Finding the slope another way. So you've probably seen this other form before. Before we were talking about equations that looked like this, right? 4x minus y equals negative 8. We called those standard form, right? Where you have ax plus by equals c. Standard form is always great. It's a great way to see everything on one side. It's very organized and clean. There's another form, though, that actually shows you your slope. You can just pull it right out of the equation. So it's very, very easy slope to work, or a very easy form to work with. It's actually called the slope-intercept form. That name is not trying to trick you or give you a whole bunch of stuff to memorize. It's trying to show you what is in the form. It's the slope and then the intercept. So you probably remember it as y equals mx plus b, which you will see down here. So y equals mx plus b. I guess we can erase that, save ourselves some room, right? But down here you'll see y equals mx plus b, where m is still the slope. That is always defined universally. M is always the slope in a linear. And b is the y-intercept. We'll come back to b when we need to use it to find equations a lot, but today we're just going to talk about that m part, that slope part. And what we're going to be doing is converting standard form to slope-intercept form, which sounds super complicated. It's really not. It's just rearranging formulas, which you guys actually, over the years, I've seen this actually seems to be a pretty easy section for people. So luckily we've got that. So here you can see we've started with standard form, right? And then we move that 4x over, so that, whoops, still in erase mode, that 4x over to the other side, we get negative 4x. And then you divide by that negative and you get everything as positive. And then this ends up being your y equals mx plus b. From there we can see, we can just pull it right out that m is equal to 4, and so our slope is equal to 4, right? So that's what it is. Alrighty. Let's try that out with a different equation. Let's take a look for the slope in this equation. 3x minus 5y equals 8. Now the goal here is to get y by itself. That's how we know we are in slope-intercept form. Okay, so we need y equals mx plus b, and then wherever the x term ends up, we will look there and we will see what is sitting next to it. So let's start with this equation, right? We have 3x plus, oh, I'm so sorry, not plus, minus 5y equals negative 8. Negative? No, positive 8, sorry. I don't know what's up with me. Equals 8. Right? So 3x minus 5y equals 8. We'll start by getting everything that's farthest away from y over to the other side. So always start as far away from the variable as you can, the variable in question. Whether it's with just numbers or with other variables, the rule still applies. Start as far away from the variable as you can. So over here I want to get rid of this 3x. Now I have a positive 3x. I'll cancel it with a negative 3x to both sides. That goes away. That way I'm just left with negative 5y. On this side, those are unlike terms. Unfortunately, 8 and negative 3x, I cannot combine those, so I'll just rewrite them next to each other. Negative 3x plus 8. You are more than welcome to write 8 minus 3x, but remember what we're after is that thing next to x, so we want to kind of set it up in this format where the x comes first. That would be more helpful to us at this point. Nothing wrong about switching it though. Alright, next, y is getting closer to being by itself, but it's not quite there. So we need to divide by that negative 5 to both sides, so that cancels and that cancels. When we do that to the other side, be careful that you divide everything by -5. Everything. If you don't like it in this format, we can rewrite it as divide this by -5 and divide that by -5. But every single term must be divided by -5. You can't just divide the -3. You cannot just divide the 8. Okay? So make sure you do that to everything. And when we finish that, we get, I'm going to go back up here, y is equal to, negative over negative becomes a positive. So 3/5 x plus 8/5. All right, so we've rearranged it into y equals mx plus b. What's our slope here? Now that we have that in slope-intercept form, our slope is what? Our slope is the m. Good, so m is equal to 3/5. And we are done. As soon as we're in that form, we can pull that slope right out of there. There's no more slope formula, no more finding points. That's why we want to put it in this form, right? To save ourselves some time when finding those other slopes. Alrighty, I'm going to let you guys pause the video now. Please pause the video and solve this one. So I want to find the slope of this. Okay, so section 3.3. This is actually the video for the first half, so we will stop about objective 5, and the other half will be on the second video. Alright, section 3.3 is about linear equations in 2 variables, which I know sounds super exciting, but it's actually stuff we've been dealing with the whole time. So these are the equations like 3x plus 2y equals 6. It's the equations that contain 2 variables. Really, you've seen them many, many times. Alrighty. Objective 1, being able to write an equation given a slope and a y-intercept. We've already seen something very, very similar to this, but we're going to review it just because, you know, it sounds like fun. So, example 1.1, find an equation of a line with slope -4/5 and y-intercept of 0, -2. So, what is given here? Well, what's given to you is the slope and the y-intercept. And remember, if you're given the slope and the y-intercept, it's so much easier to just use the slope-intercept form, right? The name tells you what is in the equation. So we want to use the slope-intercept form. Slope-intercept form. And that goes y equals mx plus b. Everyone always remembers what's in it. They never remember the name. So please make sure you remember the name, slope-intercept form, because that tells you how to plug it in. Well, we look here, we say, okay, slope of -4/5, y-intercept of -2. So I can kind of relate my variables. I know that in my slope-intercept form, my m is my slope. So here in this specific problem, m is equal to -4/5. And then here, b is going to be my y-intercept. Excuse me. But remember that b is not a coordinate point. You can't put a coordinate pair or an ordered pair into a slope-intercept form. So we need to convert this. Recall that the y-intercept always occurs at 0, something. So calling this b equals 0, not exactly correct and not exactly very helpful, right? So we want to make sure that b is equal to -2. The b coordinates with our y value. Alrighty, so now that I know that, I can go plug it in. Y equals, well, my m was -4/5, so -4/5 x -2 for my b. Awesome. Now if I want to put this in standard, well, that would be our slope-intercept form first off, and this would be enough to sorry about that. Let's just erase that. This would definitely be enough to answer the problem. But if they had actually gone out and said, write the equation in standard form, well, it'd be very simple to convert this, right? Recall that standard form has all the variables on one side, so that x plus y, this, that one up here, this is our standard form. So just go ahead and do that real fast. We have a -4/5 x, so y, let's put it in a different color so we can see it's different, equals -4/5 x -2. That's still our standard form. And we just need to move this 4/5 x to the other side by adding to both sides. So that way these two cancel each other out. We end up with 4/5 x plus y equals -2, and that would be our standard form. Alright. Cool. Now we're going to use these two forms to graph a line, which is something we've also done before, but we just want to review it real fast. So let's take a look over here. We got graph a line given the slope and the y-intercept. So here we have the line y equals 3x minus 6. What form is this in currently? What is this current form? That's right, it's in slope-intercept form, right? Slope-intercept form. So this means that we have a slope and a y-intercept. The slope here would be m, and the y-intercept would coordinate to b, right? And so our slope would be what? Yep, it'd be right here. That would be 3. And the b would be negative 6. Now the b is negative 6, but we all know that the y-intercept is never written as negative 6. A y-intercept is not a number. So this b equals negative 6 tells us that our y-intercept is 0, negative 6. Now let's use that information to graph. So again, we'll start with our starting point, our 0, negative 6. Now my graph over here goes down to 5, goes down to negative 5, and so I have one of two options. I could just add a line at the bottom here and say, okay, 0, negative 6 occurs right around there, which I think I'm going to do this time. Or I have another option. I can change these units so that every line doesn't mean 1, right? I could go by 2s or go by 3s or go by whatever I needed to, and that would be fine as well. But since it's only about 1 more down, I'm just going to add a line. If it was anything more than 1, I probably wouldn't add that line. I probably wouldn't say, you know, it's that negative 6 occurs off the graph. I would just make it go by 2s or by 3s even. Alrighty, so from here, that's our starting point. So we got start. We put it on the graph. Check. Now we have our slope. And remember that slope is walking direction. So since m equals 3, well, that's great, but I don't really know how to walk 3, right? It's supposed to be up some and over some, or down some and back some, right? So I need to convert this to a fraction. Now, remember, a lot of the time, people like to change this to 3 over 3, but 3 is equal to 1. 3 over 3 is equal to 1, right? So we don't want to say that that's the case. This is equal to 3 over 1. Always up 3 over 1, not 3 over 3, because that would be too much. That would be a slope of 1. If we just put it over 1, though, we can see that we have rise over run, much easier to read. So we're going to go up 3 over 1. And once again, we're not going to start from 0. We're not going to start from 0, 0, because that is not where we start. That is not on our line, right? Our starting point is down there at 0, 6. So we'll go up 3, up 1, 2, 3, over 1. We get our second point right here at negative 4, 1. I'm sorry, negative 3, 1. Yes, negative 3, 1. And then we'll connect the dots. Connect those dots. And we're going to extend it all the way up the graph every single time. And again, I'm not too particular. If your line's not super straight like mine, that's okay, right? As long as you've got stuff like this to coordinate and you've got your 2 points and they at least kind of touch them, that, you know, within reason. If your line's going like this, then that's an issue, but if not, then you're okay, right? You're okay. Alrighty. So that's graphing using slope-intercept form. Let's try one using standard form now. So we have this other form down here, this 3x plus 2y equals 9. And we can actually do this in one of two ways. We're going to kind of bleed into the space of this last problem. So if you want to create sort of a section so you know it's going to be coordinated to the different problem, that's fine. But so we have the equation 3x plus 2y equals 9. Now recall this is in standard form, which means all the variables are on one side. And last time we had to graph with this, we used the x and y intercepts. That's way number 1. Then we also saw that we can rearrange standard form to go into y equals mx, to go into slope-intercept form, or y equals mx plus b, and then graph that way. So you have two options here. We're actually going to do both, but I'm going to start with the y-intercept and the x-intercept first because it's actually going to be a little quicker. So let's start with that. We're going to find those x and y intercepts. So x-intercept and the y-intercept. And remember, any 2 points make a line. So once I find these two, I can graph them and then connect the dots, right? That's the goal here. So my x-intercept, recall that that means somewhere on the x-axis this line is going to cross. And that when I do that, then I know that I have no y value, right? My y is going to be equal to 0. Yeah, my y is going to be equal to 0. So let's go ahead and take that information and use it in this equation. We're going to plug it in. So this is my equation, right? And I know that y is supposed to equal 0. So I'm going to change this y to 0. So y equals 3x plus 2 times 0 equals 9 now, not 2 times y. Well, when you have 2 times 0, that just goes to 0. So you end up with 3x equals 9, or x equals 3. And so our x-intercept is 3, 0. Over on the y-intercept, it's the same but opposite, right? So if in this case, our y-intercept is going to be where it crosses the y-axis, right? And over there we've gone out nothing, so we know that the x is equal to 0. So we know that it's going to look something like that, right? You plug in the opposite. If you want the y-intercept, you plug in the x. With the x-intercept, you plug in the y. All right, so let's plug in that x. 3 times 0 plus 2y equals 9. And then because of that, 3 times 0, that goes away. So we get 3y, oops, I'm so sorry, not 3y. 2y equals 9. And y equals 4.5. So we get our y-intercept of 0, 4.5. And remember not to switch those. Just because you found 4.5 doesn't mean it's 4.5, 0, right? We still need it in this form 0, 4.5. Alrighty, so I've got two nice, pretty easy to graph points. So I'm going to go ahead and do that. Let's go ahead and graph those. I'll even graph them in the same color because I feel colorful today. So out 3, up nothing gives me right about here, and it is right on the x-axis, which is good because it's supposed to be the place where it crosses the x-axis. And then I'll do the same thing with the y. Out nothing, up 1, 2, 3, 4, and a little bit more to 4.5. And any two dots make a line. So let's connect those two, whoops, let's do it a little better. Let's connect those two dots. I'm going to extend it the whole length of the graph. And I have my equation, or my line for the equation. Alright, that's the first way. The second way would be to convert it to y equals mx plus b. So let's go ahead and do that. If I have 3x plus 2y equals 9, I need to switch this into y equals mx plus b. Subtract the 3x, pardon me, you get 2y equals negative 3x plus 9. And then divide by 2, you get y equals negative 3 halves x plus 9 halves, or 4.5. Alright. Now I can do the same thing I just did in the last problem. Well, my m is equal to minus 3 over 2. And my b is equal to 9 halves, but since I don't need it to like walk and run and all that jazz, I'm just going to call it a decimal 4.5. Right, so 9 divided by 2 is 4.5. And we'll start with that giving us a y-intercept of 0, 4.5. Which is good. I mean, it definitely should have been that because that is what we got for our y-intercept in the doing it the other way. So if those don't match, then I seriously had a problem, right? So I needed to make sure my math was right. But I did. I got the same y-intercept. So I'll go plot that at 0, 4.5. Well, that looks end up being the same point here, which is fabulous. And then we'll go walk down 3, down 1, 2, 3. And remember, I'm starting from a half here, so I'm not going down on the lines. I'm going down every half. Down 3 and over 2. And I do end up on the same line. So then I would have connected those dots and I would have gotten that same red line that the other 2 points gave me. So either way was fine. This way was a little quicker because it's very easy to go through those computations. But if, sometimes you need both of those intercepts. So it's good to know both ways, right? It's good to know that you can use 2 points. It's good to know that you can rearrange to slope. This way is a little quicker though. So if you prefer this way, no problem, no harm, no foul. But you might be asked to do one or the other. All right, if you have any questions at all, please stop at this point because that at this point should have all been review. And if it was not review and something was very foreign and new to you, you need to ask about it now because we're going to go on to a whole new form and I want to make sure that everybody's got that down. Alrighty, objective number 3. Now we're going to be given not just an equation, not a slope, not a y-intercept, but we're going to be given slope and a point on the line. So just slope and some random point floating in the universe. I've seen one version of this before, and it got a little convoluted, it got a little crazy. So we're going to introduce another form now. It's called point slope form that actually deals with this specific case. Remember, slope intercept form you use when you're given a slope and an intercept. So what do you think you're going to use when you're given a when you need to use point slope form? What are you given? That's right, you're given a point and a slope. It makes sense, right? Names never try to trick you. So point slope form looks like this. This guy right here. Y minus y1 equals m times x minus x1. And those excuse me, I've got the hiccups. Those parentheses are very important because you're going to end up distributing that m, so please make sure you include those parentheses. But you might be thinking, what on earth does that even mean? Why are there subscripts? What's happening here? Like, that's not cool. I don't want subscripts in I don't want y1s and x1s in my form. That doesn't make any sense. But remember, this is the same form as with distance formula, with slope formula. It's all the same notation, okay? So x1, y1 is just that point you're given, right? Whatever point you're given, whether it's 4, 5, 6, 8, 9, 2, whatever it is. That's just those numbers. They're just trying to tell you that these 2 points are where you plug in numbers, the y1 and the x1. And then that m is still the slope. It's all the same, okay? So don't think it's some brand new mathematical term you have to memorize. It's still the same x1, y1. x2, y2, m is slope, b is y-intercept. It's all the same, okay? Alrighty. So basically you plug it in and you solve. Let's take a look at example 1.1 so that we can actually see how this, 3.1, pardon me, so we can actually see how this works. Okay, good. Find the equation of the line using both point slope form and using the slope to intercept form. The line has a slope of 1/3 and goes through -2, 5. Alright, now they've asked us to do this 2 ways, so let's go ahead and divide the page. I'm actually going to divide the page into thirds, because there's one other thing I want to do. So just make sure you give yourself some room over here as well. But not much. I'm not going to take much. Let's start with the point slope form. Since we just learned that, we want to see what it goes through. So we've been given a slope of 1/3 and a point of -2, 5, which is awesome because our point slope form, goes y minus y1 equals m times x minus x1, right? So they take a slope and a point. Well, we've done this one a lot. We've replaced m a lot so far, so let's just go ahead and do that because I think we're pretty much on the same page there. The slope is 1/3. So the slope is 1/3, and then we've still got x minus something. The x and the y, the ones without the subscripts, those are going to end up being your same x and y that you would find in the equation. So like back in our slope-intercept form, every single time we left an x, we left a y, right? The equation's in 2 variables. So these 2 variables are going to stay variables, and that's okay, right? Eventually when we're graphing, we can plug them in, but right now they're just going to stay variables. The ones without the subscripts. The ones with the subscripts are going to be that which coordinates to our point, right? So we have this point, x comma y, this x1 comma y1, pardon me, -2 comma 5. Here our y is 5, so I'll go ahead and plug in 5 there. Here our x is -2, so I'll go ahead and plug in a -2 there. And watch out for that -2. Just because it's already being subtracted doesn't mean I don't put in a -2, right? I gotta do that. Alrighty, now we simplify a little bit. So let's simplify. Sometimes they will ask you to leave it in point slope form, in which case we would be done, right? But I just want to prove to you that they are in fact the same thing. Okay, so we're going to simplify this down so that it looks like y equals mx plus b. So we can distribute this guy in. We get y minus 5 is equal to 1/3 x minus a negative gives us a +2. +2 times 1/3 would be a 2/3. Awesome. And then we'll take care of the +5 over here because that's a little strange to have have constants on both sides. So we'll add 5 to the other side. 5 plus 2/3. That's going to be a little tricky. So let's go back up here. We'll use this little space over here. 5 plus 2/3. Well, I can't add them as they are. I need to find a least common denominator. But if I think about the fact that 5 whole pies has 15 thirds, then I can convert this to 15 thirds plus 2 thirds, right? So that's the same thing as a 5. And now it looks like I have a total of 17 thirds. So 5 plus 2 thirds is 17 thirds. You want to leave it as a fraction. I know some of you are addicted to your calculators when it comes to adding fractions, but right now I would like you to leave it as a fraction, just so you can see what we do later on. But there we go. And we end up getting y equals mx plus b, or y is equal to 1/3 x plus 17 thirds. Awesome. Now we're going to go on and do the exact same thing in slope-intercept form, which we've seen before, but with the fractions I think we need a little practice. So we have y equals mx plus b, that's our slope-intercept form. And recall that this only works, you can only plug in directly to b if you're actually given the y-intercept. Remember, b means the y-intercept. Here we're not given the y-intercept, so it takes a few more steps, right? We are given the slope though, so let's start with that. Y equals 1/3 x plus b, right? 1/3 x plus b. Now let's plug in that point, but we're not going to plug it into b, right? We're not going to plug it in like we did in our point slope form. We're going to plug it in as a point. So our x comma y are going to become the x and the y here. So 5 is equal to 1/3 times -2 plus b. Solve that out, you get 5 is equal to -2/3 plus b. Add 2/3 to both sides, and when we do that, we still have that same 5 plus 2/3, right? So notice it's very, very similar. Very similar, just kind of rewritten. You still get that b is equal to 17 thirds. And so our final form is y equals 1/3 x plus 17 thirds. Awesome. So either way, you were given the same thing. Now, point slope form did take us a little bit longer, only because we've never seen it before. But they're about the same work, right? They're about the same. Sometimes point slope form is actually faster because you don't have to remember you have to plug it back in. Sometimes you can avoid the fractions. So I prefer point slope form whenever I'm given a point and a slope, but it is excuse me, up to you. I have the hiccups. Okay. The last thing we want to do is taking a look at this. This is not a very pretty equation, right? It's a lot of thirds. So instead of leaving this in slope-intercept form, let's change it back to standard form. Remember, standard form looks like this with x and y on one side. And so let's do that. So let's start with our slope form, our slope-intercept form. We have y is equal to 1/3 x plus 17 thirds. And notice how many times I'm saying thirds. In order to get rid of all these thirds, I'm just going to multiply by that bottom. I'm going to multiply by 3. Multiply by 3 to both sides. So if I multiply 3 on one side, I have to multiply by 3 on the other. If I do that, then this third cancels with that, and this 3 cancels with that. So when I do that, I end up getting a 3y is equal to just 1x plus 17. So I've moved essentially the 3 to the other side, right? That looks already much prettier, but that's not actually a form of any kind, so I have to go one more step. I have to change that x to the other side, and I get a standard form of -x plus 3y is equal to 17, and that just looks so much better. Nice whole numbers compared to this nonsense over here. Now, are the y-intercept form incorrect? Absolutely not. No, that's definitely a valid equation, right? And it's okay to have fractions. But sometimes if you maybe want to, whoops, sorry, I didn't mean to draw on that. If you maybe want to impress people more, or you want to be nice and clear, coherent in your reports or whatever, sometimes you want standard form as well. And so being able to convert between the two can be pretty important. Alrighty, let's try out another one. Let's try out, so now, let's do the same thing. But we're going to convert between, or sorry, we're going to use it given 2 points. So we're not going to do quite another one the exact same, but it's almost exactly the same. It's almost exactly the same. This time we will be given 2 points on a line instead of the slope and a point. So it's just one extra step. Remember to pause the video at any time if maybe I'm going too fast, you missed something, you have a question, right? Please make sure you pause and get your questions answered. Okay. Alrighty. So given 2 points, we need to find something else. So it seems over and over and over again, we need to end up finding our slope and our y-intercept, or our slope and our point, right? And so notice slope keeps appearing over and over and over again, no matter what form we're in. Standard, yes, the slope is there, we'd have to go find it, but in our other 2 forms, we need to find the slope. And so the same concept relies here, appears here. We need to find that slope. So let's take a look at example 4.1. Find an equation of a line through the points negative 4, 3, and 5, 7. Write the equation in standard form. All right, this time it actually asks us to find standard form as well. So let's make sure we divide that page up into those 3 sections so that we can do all 3 things that are asked. Now, on a test or in real life, you will not have to do it both point slope and slope intercept form way, right? That's really a personal choice. It depends up to you. Right now during the notes though, just so we get used to this and get used to how to be able to work with both of these, I will be doing both. So we're going to do both. We're going to start with, we'll end up doing both is what I'm trying to say. However, before we can do anything, we need to find what? What did I just talk about that we needed like 16 times? We need the slope. They didn't give us the slope, and that's a problem. So to find the slope, when given 2 points, what can you use? Think way back when. Give you a hint, it's also in my box. That's right, the slope formula. We need to use the slope formula. y2 minus y1 over x2 minus x1. Nothing in this class ever really goes away. So if I tell you to commit something to memory, you better commit it to memory. Like, how many of you remember the distance formula? That's what I thought. All right. So make sure you know those formulas, okay? So we need to find the slope formula now. If we don't know the slope, we need to go find it. But we've done this so many times before, we can find it real fast. We'll call this one our first point, this one our second point. So we'll subtract the y's. Second y minus first y is 7 minus 3. Over second x minus first x is 5 minus negative 4. And we compute that out a little bit. We get 4 over 5 minus negative 4 is the same thing as 5 plus 4, or 4 over 9. And that, you really can't reduce anything. So that'll be our slope for this problem. Alright, that's the first thing we needed to find. Find that slope, so number 1. Now let's go try point slope form. Now we have a slope, we have a choice of point, right? So we have 2 points actually. They gave us more points than we needed. And we can go use our point slope form. Point slope form looks like y minus y1 equals m times x minus x1. Alright, I can plug in that slope I know, the one we just found. Everything else I'll keep the same for a moment, but I plugged in that m of 4/9. Alright, so let's take a look at these points now. Do you think it matters which point I actually use? What do you think? You're right, it does not. I can use either point. Either point will give me the correct answer, because at the end of the day, we're going to be rewriting it in standard form, so it wouldn't matter, right? And off on a test, you use the first point or the second point, and you were told you could leave it in point slope form. Either one would have been the correct answer, because they end up simplifying to the same equation. Totally fine. Since I'm not a huge fan of negatives, there's nothing wrong with them, but people tend to like positive numbers, I'm going to go with this second point here. I'm going to use 5, 7. Now be super careful. This first part is not going to be y minus 5. Why? Why would it not be y minus 5? Think about it. That's right, because y is 7 here, right? In the point, the y is 7, and I see that happen so many times. So I'm going to plug in, and it's got to match. Y minus 7 times 4 over 9 times x minus 5, right? x1 is 5, y1 is 7, right? So I've got to make sure I do that. Then we simplify. Y minus 7 is equal to 4/9 x. Let's see, 4/9 times negative 5 would be negative 20 over 9. Just multiply the top, right? Multiply the top. And I actually don't need this parentheses anymore. Okay, cool. Well, that's still not very pretty. I'm kind of running out of room, so I'm going to go ahead and go up to the next part here. Add 7 to both sides, right? And you get y is equal to 4/9 x, let's see, -20/9 and 7. So 7 would be 63/9, right? Just like 5 is 15/3. And then minus 20 would give us 43/9. That isn't quite a mental computation for you. Go ahead and pause. Mr. Walsh or the sub, whoever it may be, can show you on the board, or we can, or you can go ask questions. They can do it on your paper, things like that. But it does end up being 43/9. Okay, cool. And that would be our point slope form. All right, just to prove it works the same for either way, let's go ahead and just section that off, and we will do it the other way as well. So we start with our slope-intercept form this time. Start with slope-intercept form, y equals mx plus b. Again, we use the slope that we just found. We must do that first because for either one, the slope is necessary, right? Either one, the slope is necessary. So y equals 4/9 x plus b. And then this time, this x and y are not just generic that we leave in there. We actually use them to solve for b. Sorry. So yeah, we have to use them to solve for b. We can't just plug in 4b. They did not give us, neither one of these points is 0, something. So neither one of these points is actually our y-intercept. Instead, we can choose either one. Again, I'm going to use the same one, 5, 7. And I'm going to plug in and solve for b. So 7 is equal to 4/9 times 5 plus b. And again, I've run out of room, so I'm going to go up here. I'm going to go up here. I have y, oh, no I don't. I have 7 is equal to, well, 4 times 5 is 20/9. Plus b. Wow, this is a very, very similar to what I'm seeing over here, right? So that's what I'm saying. It's exactly the same. Either you keep the x and y in or you don't keep the x and y in. Either way, you're going to have to deal with fractions in this problem. And that's okay. We'll figure it out. Subtract 20/9 to both sides. You end up with b is equal to 43/9. And again, we end up with y is equal to 4/9 x plus 40. Okay, you know what? I'm going to scooch it over just a little bit so I can actually fit it on the page. Y is equal to 4/9 x plus 43/9. We get the same thing either way. So again, it's a personal choice. I prefer point slope form. I don't know why. It's about equal work, right? But it's up to you, whichever one you want. You end up with the same thing. The last thing I want us to do is convert it to standard form, and we've already seen one of these in the last problem, so luckily we can do the same thing. I'm going to start off with y equals 4/9 x plus 43/9. Notice how many times I'm saying ninths. Ninths. If they match, it's super easy to know what to multiply by, right? It's not always if they match. If they match, you got to find something they have in common. But for here, it's very easy to just to discern what we should multiply by. If I want to get rid of these 9s on the bottom, I can multiply by 9 to both sides. And I end up with 9y is equal to 4x plus 43. Those 9s just kind of go away, right? Moved them over to the other side. And then, of course, this isn't actually a form. It's pretty. It's got nice numbers and nice whole numbers, but it's not a form. We have to have all the variables on one side for standard form. So we'll subtract the 4x to both sides, and we end up with negative 4x plus 43. Oops, I'm so sorry. Not that. Negative 4x plus 9y equals 43. And that is our standard form. Alrighty. Pause the video now if you have any questions about converting between these three forms. Whether you're going through point slope form, slope intercept form, or standard form, please make sure you get those questions answered, okay? Alrighty. The last thing we're going to be talking about today is finding the equations for horizontal and vertical lines. So horizontal and vertical. let's start by making ourselves a little note bubble right over here, because we review some things about horizontal and vertical slopes. Alright, so horizontal. Remember, horizontal lines, they run from side to side. Perfectly straight lines. And because they do that, they have no rise over some run. And because of that, they have a slope of 0, right? So it's okay to have no run, or no rise, right? It's okay to just keep going forever. You just have a slope of 0. You rise nothing. Whereas a vertical line, sorry guys, I'm going to rewrite that because that was really big, and I want to save some room for the vertical line. So 0 over equals 0. Alright, so the vertical line goes up and down, right? That's the vertical line. And since that goes all rise over no run, well, you can't divide by 0, so that slope does not exist, right? That's what that slope means. That does not exist. So horizontal, slope of 0. Vertical, slope does not exist, right? Alright, cool. That should have been review. Now, just because the vertical slope does not exist, it doesn't mean that the vertical line does not exist, right? And it's pretty obvious because the vertical line's right there on the page. I just drew one. Definitely exists. So it must mean that it has an equation. Just means that it probably doesn't have an equation that that looks like our other ones, right? It doesn't have an equation that looks like this. Both of these are a little more conceptual than they are arithmetic. So you don't just solve for this with these guys. You got to think about it. You got to think about, okay, what am I looking at here? So let's go take a look at 4.2. Find the slope of a horizontal line through 2, 4. So we've got this horizontal line, right? It's going through. It's got this nice horizontal picture. And eventually it hits the point 2, 4. But for now, let's just look at it as a horizontal line. Well, we know that horizontal lines have a 0 slope, and so they look like y equals something, right? Y equals something. Y equals 0x plus some b. You can think about it that way. Y equals 0x plus some b. And because it's a 0, you don't really need to write that, so it's just y equals some b. Right? Now, what would this b be? Now, it could be the y-intercept, right? It's definitely the y-intercept, still definitely the same thing. But there's an easier way to think about it. Let's take a look at that point again. At some point, this line's going to hit, at some point in time, it's going to hit this coordinate 2, 4. And so in order for this equation to go through that point, what does the y need to be? That's right, it needs to be 4. If it didn't go through there, if the y wasn't 4, then it wouldn't go through 2, 4, right? The y value has to match. Remember, this is the point that goes through everything where y equals 4. So to find the equation of a line that goes through a point, you just look at the y value. Let's take a look at the next one, because it's very, very similar. Very, very similar. Find the slope of a vertical line through 5, -6. Well, we've got this nice vertical line, right, going up and down. And at some point, it goes through 5, -6. Whoops. That's not what I wanted. Sorry. 5, -6. Now we know it's not going to be of the form y equals because that has a 0 slope, right? We want 0y, we want no y. So this is going to be of the form x equals something. Since this x equals something has to go through 5, and for 5, -6, that means the x has to be all the 5s, and that is the slope, or the equation of our vertical line. So as long as you can keep track of horizontal is y equal, vertical is x equals, then you've got it's very easy to find horizontal and vertical lines, right? Alrighty. That is pretty much it for today. We're going to take a quick review of what we talked about. We talked about finding a slope, or finding an equation given a slope and a y-intercept. Talked about graphing said version. We talked about finding an equation giving a slope and a point, given 2 points. And then we talked about horizontal and vertical lines and their equations for those. So if you have any questions on that, please make sure you review, get your questions answered, and we will do the second half next time.